We all think we get gravity, right? You know, the thing that keeps our feet on the ground and holds the solar system together. But what if that's not really the whole picture? What if the way we've always thought about it is just wrong? Let's dive into a totally different way of looking at reality. So here's the big question. What if gravity isn't a force? What if it's not some kind of invisible rope pulling everything together? Seriously, just thinking about that question, it changes everything about how we see the cosmos. And it's the key to unlocking one of the most elegant and beautiful ideas in all of science. You know, for hundreds of years, we were all on Team Newton. His idea was simple. Gravity is just an invisible pull between any two objects. Makes sense. But then Einstein came along and, well, he just blew that idea out of the water. He said, no, gravity isn't a force at all. Instead, it's just what happens when things move along the simplest path they can find through a warped fabric of the universe, something he called spacetime. Okay, I know what you're thinking. A warped fabric of the universe, that sounds super abstract, right? So how do we even begin to wrap our heads around it? Well, luckily, there's this fantastic analogy that makes the whole thing click. It really makes it tangible. All right, let's try this. Picture spacetime as a huge, flat, stretchy rubber sheet. Pull tight. Got it? Now, let's take a heavy bowling ball. That's our sun, and drop it right in the center. What's it going to do? Of course, it's going to create a big dip, right? A curve in the sheet. Okay, now, let's roll a little marble. That's the Earth, nearby. See what happens? The marble isn't being pulled by the bowling ball. Nope. It's just following the curve that the big ball made in the sheet. And that's the absolute key to this whole thing. It looks like the little marble is being attracted to the big bowling ball. It seems like a pull. But what's actually happening is that the marble is just trying to go in a straight line, but on a surface that's now curved. And that right there is gravity. It's not a force pulling things. It's just geometry. And yeah, there's a technical name for this, of course. It's called spacetime curvature. It's the mind-blowing idea that anything with mass and energy literally bends and warps the fabric of both space and time around it. And that bending, that's what we feel. That's what we call gravity. Okay, so if this is all about the shape of the universe, what are the rules? You know, how does this whole bending thing actually work? Well, it turns out the rules are pretty simple, but their consequences, whoa, they shape everything we see out there. The rules are actually super intuitive. Rule 1, the more mass you have, the bigger the curve you make. Simple. A heavy bowling ball makes a much deeper dip than a tiny marble. So when we talk about stronger gravity, what we're really saying is steeper curve in space-time. And here's the kicker, the part that really messes with your head. It's not just space that bends. Time bends too. All right, so we've got heavy things making curves in space-time. The next obvious question is, what or who has to follow these curves? Is there anything that can ignore them? The answer is everything. And I mean everything. Nothing gets a free pass. Every single thing moving through the universe is guided by these curves. It's not a choice. Planets, you, me, spaceships, and get this, even things that have no mass, like light itself, have to follow these paths. And this isn't just some wacky theory. We see the proof of it everywhere. The Earth going around the sun, that's just our planet following the huge curve the sun makes in space-time. Ever hear of gravitational lensing? That's when we see light from a distant star literally bend around a massive galaxy. It's light following the curve. And for the most mind-bending proof of all, time actually slows down near massive objects. It's a real thing called time dilation, and your GPS wouldn't work if we didn't correct for it. How cool is that? So, okay, force, geometry, what's the big deal? Why does it even matter? Well, it matters because it completely rewrites our entire understanding of the universe we live in. See, this isn't just like upgrading your phone from one version to the next. This is a total paradigm shift. It replaces the old idea of a force with something so much deeper. It tells us that the rules of the universe aren't just random forces acting on things, but they're literally woven into the very fabric, the very structure of reality. And what this all leads to is a single, beautiful conclusion. The path of everything, from an apple falling from a tree to entire galaxies swirling through space, isn't being controlled by some mysterious, invisible pull. It's simply following the shape, the geometry of the universe itself. So if you're going to remember just one thing from all of this, let it be this elegant little summary. Mass tells space-time how to curve, and curved space-time tells mass how to move. That's it. That is gravity. Kind of makes you wonder, right? If the most familiar force we experience every single day is really just the shape of reality, what else is out there? What other huge secrets about the cosmos are hiding in plain sight, just waiting for us to realize they're not forces, but just geometry?